Hi guys, welcome back. What's happening here is I'm about to test the down counter. I've finally found time to get all the wiring done, and I'm just pulling out all the chips for the up counter just in case I've got something wrong and I don't want to accidentally destroy them all. I'll be amazed if this works out the gate. Right. Done a lot of checking today, and I've had enough of checking. It's just time to give it a go, basically. Now this blue wire is for the up counter, so I'll just disconnect that for now. And let's jam this wire in. It's going to be our down counter, 1 digit. So pin 3. Yep. Let's just give it a go. Something's not right there. Oh, something's happening. I got that going too fast. Where's my screwdriver? Yeah, something's wrong. Alright, let me find out what's wrong and I'll get back to you. Alright folks, I'm back with some progress here. I had a couple of issues here with my circuit. With the down counter circuit, what I had was there was an LED here that was sort of blipping every now and then whenever I had a clock signal for the up counter. They should be independent, and so anyway, I traced the wire going from that LED through the transistor and whatnot, and it's coming down through here to this cluster of white cables, and it was this particular white wire here. I snipped that to troubleshoot it, and sure enough that LED stopped blipping, and so anyway, in closer investigation I found that that wire was actually joined to a neighbouring, no, the wire was joined to pin 15, which is the actual clock signal for the down counter. So that fixed the blipping. Whenever I had the clock signal triggering for the down counter, a stray LED there was blipping, right? So anyway, so this board has all these tracks running down here, and when you want to cut a piece, you basically push this in a hole here, and then you just, you know, rotate it back and forth, and it'll cut the track. Well, the wire coming in here, I basically just hadn't cut it properly, and it was joined to this clock signal. Anyway, cut that fixed that problem. Then the second problem I had is these LEDs were mimicking the top LEDs in the top counter. Again, they should be independent. So anyway, in closer inspection there, what I found was the jam signal for the bottom counter. If I put a positive going pulse on there, whatever's on this display will get jammed onto this display. But which is pin 1 on these chips here, pin 1, pin 1, pin 1, pin 1. They were all joined, but they were floating, and they shouldn't be floating. So basically I tied that to ground with a 10k resistor, so they're all low and ground. I fired it up, and that fixed that problem. The LEDs weren't being mimicked, and once I jump this wire into the clock here, then success. It started counting downwards. I never had the chip for that display, and all I saw was these LEDs. And yeah, so that was not too bad. Easy fix. Let me just try and get this wire back in there. Cool, the final test for the up and down counters. Again, it could be random. We'll see what happens. That was probably a B. 4. Oh, something's wrong. Oh, check it out. We've got both up counting here, down counting here. So this is the up counter, the blue wire. It's a down counter. So we can count up the blue wire, or we can count down on this display with the orange wire. Okay. Or we can have both at the same time. So we're making good progress. So the problem I had with this digit here, same thing as before. I had not cut some of the tracks properly in the back here, which basically involves, just grinding away the copper there with this tool. So I just went around in that area, done it a few more times. Yeah, it fixed that right up. So what I'm going to do now, before I hit the sack, I'm going to try and jam this display to whatever that says. But before I do that, I'm just going to rush out to the workshop, grab some zip ties. I'm going to zip tie these cables here, these wires, so that we can see these displays a bit better. And yeah, let's get this jam signal happening. Once I get that jam signal happening, I can rest easy tonight. Let's go with that for now. Let's hope I haven't messed anything up. Okay, count up with the blue wire. And count down with the orange wire. Again, this is blank, and this could start up with any random number between 0 and F. F is a hexadecimal digit. But once we get in between 0 and 9, we'll be all good. So this should come around shortly. Here we go. Yeah, so you can configure these counters to count in, let me just see what the data sheet says. What the hell do they call that? Binary or decade counter. So with a 4-bit binary, you can get up to F. So 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And then back to 0, and then 1, and so on. And then once you set it into decade counter, then obviously it'll only count in the decimal system, 0 to 9, and that's it. So what's happening is when we power it up, it's just randomly at some sort of number. At some point, I'm not going to get into that right now or immediately, I may need to provide a reset signal to reset that into a certain area that is ideal for the circuit. But I know from experience, once I get all the logic happening and everything, that may just self-cure itself just because of the nature of the beast, So let's just flick the light off so we can see it even better. Yeah, looking pretty cool. So I'm happy with that. Let's just get the other one going again. Okay, now what I'd like to do is see if I can provide a jam signal, and we'll jam this to read whatever that says. So let's get a bit of wire. Since it's positive going, we'll use red. Power on. Okay, let's simulate. We're going to pull our cable out, and as we're pulling it out, this display will be counting up. Once we get to the length that we want, we stop pulling, and then we put a jam signal on here, and whatever that's saying, sorry, whatever that says, that should say. Let's try that. Oh, check that out. And then we can then start this to count down. Let's put a feed in there. Oh, it's this one. Oop. There you go.